I'm going to talk to you about seafood in a world dominated by climate change, and my presentation follows very neatly the previous presentation on biodiversity in the Arctic, but also the previous discussion on the panel with indigenous people. The FAO has three objectives: to end hunger, to end poverty, and to maintain resource sustainability. These three objectives challenge each other. There are trade-offs in achieving them. And for the first time, about 2 weeks ago, the FAO, for the first time in many years, had to disclose that the number of undernourished people has increased this last year. After declining, particularly in percentage, but also in absolute terms, for many years, then last year it increased as a result of two things: climate variability, change, and conflict, political conflict. So we have now more than 800 million people that are undernourished, and it is the task of the UNFAO to make sure that that declines. Now, we have estimated already this year in a report called The Future of Food that by 2050 we need to produce 50% more food than we produce now. That is a big number, but also we need to understand that from 1960 to now we have tripled the amount of food that we produced. So it's not so much the volume that is an issue, is where does it come from and how do we actually maximize it. Now, for a very long time, many agencies and the United Nations in particular have recognized the incredible value of fish as nature's superfood in so many different aspects, which I have listed there and I will not repeat. Securing the access of fish to feed the world is crucial to achieve the target that I mentioned early on and to reduce the number of undernourished people. Now, fish not just come from the sea, it comes from inland waters and increasingly from aquaculture. What you have in this slide is the trend on fish production from the 1950s to now. In blue is marine fisheries and in orange is aquaculture. In green, by the way, is the fish that is not used for food but is used for other reasons. For example, to feed animals, and that has been declining over time, which is a good trend. The careful management of this process has allowed a per capita consumption of fish of around 20 kilograms per person per year. This is double what it was in the 1960s, and it is a very good thing, but of course it has trade-offs, as I will speak to in a moment. Perhaps more importantly, we have now the challenge of climate change to focus on. And for those that might have actually seen the IPCC reports, this figure here shows where does the heat that we have produced, the extra heat that we've had produced as a result of anthropogenic climate change, is sitting on. And 90% of it, over 90%, is sitting in the oceans. In light blue is the surface oceans, and in dark blue the deep oceans. So ice is in white, land is in orange. The atmosphere is the tiny, tiny bit maroon bit at the bottom. So the ocean is really accumulating the majority of the impact of climate change in terms of temperature, and that is causing significant changes. There have been predictions over what this will mean for the future of the oceans. This is one of such predictions by my good friend William Chong in Fish and Fisheries some time back, predicting an invasion of species into the Arctic as a result of warming of the ocean and the retreat of the ice, of the sea ice. Also local extinctions, particularly in the tropical regions where biodiversity is expected to decline, but in the Arctic it's expected to increase very significantly as that result. Now, how does that turn into potential fish production in these regions? I'm going to show you a figure that is not yet published. It's going to be published soon, we hope. It's a paper currently in review, combining all the available models of fish prediction, running and driving them from the same drivers, and understanding then what is the potential mean change in total fish biomass in 2100 on the left relative to 1995. And on the right is how variable the models predict such a signal. And what you see in the left, the areas in red are the areas with the total fish biomass is expected to increase significantly. And that is throughout the Arctic region. Not all the models predict that. There's a lot of patchiness in it. But this is something that we know that we are already seeing. And to provide you one example is the case of the Atlantic mackerel, very well known in Iceland, has been expanding northwards. By 2100, in the figure on the right, you see the area in green. That is the area where it's supposed to be expanding further. So we already see quite a few species that are changing their distributional habitats as they follow thermal preferences. Not all species can do that, of course. Some of them are attached to habitat and attached to other reasons that are not thermal preferences, but those that do have a thermal preferences would expect to move and shift. Now, there is a huge elephant in the room, and that is the sustainability of fisheries overall. The FAO produces every 2 years a state of global fisheries, and this figure is repeated every year with an extra data point. And the last one is this one that was produced last year, showing that 31% of the fish stocks globally are overfished. 31%. 58% are sustainably fished, which is not something that people pay much attention to, unfortunately, but it is actually a volume that is increasing. But tragically, the percentage of overfished stocks continues to increase. We are finding it difficult to stabilize that figure. And we see increasingly a very clear difference between what's happening in the developed world and in the developing world. So you can see it in this figure. The top is landing, so volume of fish caught, and in the bottom, the effort, the fishing effort. If you focus on the bottom one, the fishing effort, in developed countries, that's the orange line, the effort has been declining over the last 15 years or so, and as a result, the catches have been coming down because we're exerting more control and biomasses are rebuilding. But in the developing world, that's the blue lines, the effort continues to increase. We are finding it difficult to translate the successes that we have had in the recent decades in the US, in Canada, in Europe, throughout into regions where management is has less political support and less financial backing. And this brings a huge challenge to the fact that we're going to have to adapt to the changes that climate change is bringing in a situation where different countries and different regions have very different standards of management. So just to give you an example, this is the figures from the European Union. On the right is the spawning stock biomass, so the total biomass of fish in European waters. The blue line, which is going up from the middle of the 2000 as a result of stringent controls and a reduced fishing effort, that's a dotted line. Now, management happens in fixed regions. On the left, what you have there is the different regions from which we actually manage fish stocks. If fish stocks start moving from one region to the other and beyond these regions, how do you manage the process? As you have lost the mechanism for which you were controlling that management. This is what is going to be an incredible challenge over the next few decades. I'm almost finishing, and I'd like to just mention that climate change has primarily negative connotations, of course, no one would deny that, but there can be some positive impacts if we manage to harness them properly. No future generation is going to thank us if we don't actually do that. And I think that one of the things that we need to do in terms of harnessing the few positives of climate change and minimizing the many negatives of climate change is to make sure that we adjust our management, that we are developing fisheries management processes that adjust themselves to change. Fisheries management is very adjust to variability, but not to unidirectional change. So that is requires institutional changes as well. So how do we actually manage resources that might actually cross boundaries, borders, much more than they did in the past? The second, and I would be saying that working for the United Nations, is that the international cooperation and policy is going to be crucial if we want to maintain fisheries as a mechanism to feed the world. This is the only mechanism, in fact, to balance what I have been calling for some time, the debate about winners and losers. Climate change is going to bring winners as well as losers, I'm afraid. And unfortunately, when that happens, you have to reconcile the benefits and the difficulties of both of these groups in order to maximize the benefits for all. The third one is that we have to accept, and that has not been yet the case, the need for very profound adaptation in the way that we manage natural resources. It's not just about complaining about change happening, it's about doing something about it that makes sense. If we don't adapt properly, we will actually challenge ourselves and gear ourselves towards failure rather than success. It is possible to maximize the benefits and minimize impacts through adaptation. But if we don't do so, if we don't act properly, we will maximize the impacts and minimize the benefits. In the next few decades, the human race is going to face a number of incredible challenges, and nothing more challenging than feeding the world. And we need to look at the resources differently. The ocean occupies 70% of the Earth, but in terms of protein production is a very, very small percentage. There isn't much you can do to increase the protein on land without destroying huge habitats that need protection. So if we need to feed the world and we need to provide protein, we have to find better mechanisms to generate more protein from oceans. And I'll leave you with that thought with 15 seconds to go. Thank you very much.